Okay, lesson set 32 coming your way. Problems 40 to 107. The problems before number 40 are more algebra 1, closing up those gaps, and that's on you now. Those are still going to be given on the test. So you have the worksheets, and we're going to do odds one day, evens the next, but I'm not going to put anything from 1 to 40 on these videos. All right, if you want to when I do the videos for odd and evens on the test videos in a couple of weeks. For anybody who hasn't seen those 40, just go back to lesson set 1 through 25, and you'll get explanations for those problems and some practice. All right, so with volume like this, doing this volume and getting these things in front of you so you can get some practice, anticipate a careless error or two. This course, I made some notes to myself. This course is based on learning from your mistakes. I made 2 or 3 on the last video. I remember where they are. One I can't believe I made, but we'll get to that, and then I'll talk about it when I get to that problem. TT, I put something down there to remind me what I wanted to say, and I can't even remember what T stands for. But this is about recall. And if you're going to work with this material, you've got to take it into future classes with you, and you have to recall all of these foundational principles in order to study at higher levels. I'm sure this is somewhat a spatial repetition course. And what's the exact number of problems you need to see and how often? I got a colleague, Professor Flynn, who's working on that, data guy. And he's keeping track of learning curves, and we're having some fun with that. And bright young man, I'm sure he's going to add some great comments to how many times we need to do this and how we should space it out. So that's coming, and I've got my eraser, I got my marker, and so now we're just going to take off, and you pause the video when I get to a problem and try it. If you need to, if you look at it, you can just watch me do it real quick. And that's enough practice on that problem for a day. And if you keep doing that day in and day out, should become, as Yasser would say, easy peasy. All right, so let's have at it. And I'm going to erase these as I go and hope I don't get into trouble, because it took me 20 minutes just to put these problems on the board. All right, here we go. So the ln of e to the 8 over e to the 9, well, that's e to the minus 1. And I'm multiplying here, power to power, and I'm looking at the answer of 2. 4x minus 8. 2 is critical. X plus 2, negative 2 is critical. Pick a number bigger than 2. Let's put 10 in here. That's a positive. That's a positive. And a positive divided by a positive, if I'm not mistaken, is greater than 0. So that's true. That's going to be false. That's going to be true, because we're going to get sign changes. You try some numbers and see that that's the case. I don't have or equal to, so these numbers don't work. What works? Negative infinity to negative 2, union 2 to infinity. And we don't graph these. It would take too long to graph. Well, not really that. It would take a little while to graph. So that's a quicker way for rational functions. This simply means, do you know that 3 to the negative 4 is equal to x? That's all. That's just the inverse operation to get our answer. So 1 over 81 is that answer. All right, let's get some space here. Hypotenuse is 10. Remember, we did this yesterday in the last lesson. Said if that's 1, that's root 3 over 2, which is really 1/2 times root 3. And this is half of that. Okay, so those are your ratios. So what happens when I make this 10 times bigger? Whoa, 10 times bigger. Well, that hypotenuse is now 10. This is now 5, and this is now 5 root 3. So I hope you can see that that's the factor that connects the middle and smallest lengths of a 30, 60, 90 triangle. There you go. I probably should have put that in there for you. All right, so those are our other 2 side lengths. We've just figured out what x and y are. Very important for your SATs. All right, so this should be old hat. 5m minus 2y, those are the cube roots. I square the first term, 25m squared. I do the product, minus 10my, but I change the sign, positive 10my, and I square the last one. And if you multiply this out, you'll find if you multiply that out, that 4 of the terms cancel, but the beginning and the end do not. Write as a product. WAAAP, write as a product. Okay, I won't be doing that too much more saying it because we'll know. First rule of factoring, yeah, you can see that. Take out what's common. So that's x squared minus 3x minus 4. Then see if you can continue, and we can. X times x squared. I need 4, so that's going to be a 1 and a 4. And I need it to be negative, so that gets the negative, that gets the positive. And Rene Descartes and I are moving along. Okay, hopefully we can see everything. So I like columns, so minus 2x to the 4th. Minus 2 times minus 3 is positive 6. So I'm trying to be careful. X squared times x is x cubed. Minus 2 times 10 is minus 20x squared. This is the ones I make more mistakes than anything because I'm in a rush. Minus 10x cubed. I'll put that in the cubic column. Positive 20x squared. Positive 20x squared. Oh, isn't that nice? And minus 5x. I think I've got this right, but I'm not checking anything. So I've got minus 2x to the 4th. Looks like minus 4x cubed minus 5x is the answer. I couldn't write that over here because I need the space to do the problem, but we'll get familiar with it from a video standpoint. So I can get rid of that now. All right, this one I made a careless mistake at the start of the last lesson set. So I'm going to flip it. That takes care of the minus sign. And then 1/2 means square root. So that one is 8. All right, there we go. All of these are perfect quartics. Hope I can use that term. 4th root of 16 is 2. The 4th root of x to the 4th is x. The 4th root of y to the 20 is y to the 5. And the 4th root of z to the 8 is z squared. And the numbers speak for themselves. Square root of 2 times the square root of 14 is 2 root 7. So root 2 times root 2 root 7. We can see the 2 root 7 come from that. Root 2 is buried in root 6. So root 2 times root 2 is 2. Times 2 is minus 4 root 3. And you'd have to do the same kind of construction here to get there. All right, so that hopefully is correct without carelessness. But as I say, talking to you and doing the problems, I don't do it as well as I used to. And as I get older, I seem to make more careless errors. So I'm adding 8 to this side. I'm dividing by 2. I'm doing the inverse of E, which is ln. And I'm adding 7, and I'll just do that there. There's your answer. And ln of 5 is approximately 1.6. I'll keep saying that because I don't know if people are looking at their memorization sheets enough. So we'll reduce this first. So the cosine, I'll take a 3 out, minus 7 pi over 2. Those are the quadrantal angles. That's a 90-degree angle to our triangles. And we're going back 7. So that's back 4 pi over 2. Right? And so I got to go another minus 3 pi over 2. Well, that's minus 1 pi over 2, minus 2, minus 3. I'm right here. Okay, that's where minus 7 pi over 2 is. Straight up. And I'm looking for the width of this triangle, which is pretty hard to draw. Almost impossible to draw. In fact, I can't draw the triangle. I can draw something near it. So near it would be maybe there. And if I drew a triangle, right, the width is pretty small. As I move towards that location, the width goes to 0. So that's what that is. If I was going to graph the cosine function, that's in the positive direction. That's in the negative. And I'm here. Right? I should be there. So this is 180, 360. Now I need 2 of those, right? So I'm over here, I believe, from a graphical standpoint. All right. That was that. I am going to erase these as I go to save myself a little time. No, I won't. It's your time I'll be wasting. So I'll retract that statement. All right, ln of 2/9. Well, that's 0.7 as an approximation. That's 0.7 minus 2.2. So our answer is going to become what? Minus 1.5. All right, so that's our approximation. Now, where did it come from? Well, 2 is E, well, we want the rules of logs here too. So the rules of logs, and you're going to try to see the rules of logs. Ln of 2 minus 2 ln of 3 is what is going to emerge from this notation. So e to the 0.7, 2/9 is approximately e to the 0.7 divided by e to the 1.1 gets me 3, and that gets me 3 squared. So this is an approximation for that. I hope we can see 0.7 minus 2 times 1.1. And now maybe that'll have more meaning for you. All right, this 2 could have been placed here. And now I'm looking for the exponential activity. 3 is e to the 1.1. All right, I'm hoping you can see 2 times 1.1 here. And it's in the denominator, right? So we're subtracting exponents. All right, that's a conversation you needed to have. We had it. Okay, I've got to get a new marker cartridge, so that's going to take just a second. There we go. There we go. Oops, come on. There we go. Back up and running. All right, so this is compound interest, which we will talk about in greater detail later in the term. Right now, we're just trying to get down mechanics. So on the worksheet, it said $100 gets doubled. So we're taking $100 at e to the 6% is 0.06t. And I think I wanted to double it. So if I want to double it, then I definitely want 100 e to the 0.7. So the 0.06 has to equal 0.7. All right, got to solve that algebraically, but we would divide first. There's our 2. E to the 0.06t. I'm going to do the ln of 2 to get 0.06t. There's our 0.7 equals 0.06t. There's our 0.7 divided by 0.06 equals t. Multiplied by 100, we get 70 divided by 6. What's that? 10, 11, and 2/3 years. 11 and 2/3 years. Yep, 5% from yesterday was 14 years. A little higher interest rate in that savings account. Takes less time to double. That makes numerical sense. All right, so let's erase that, make some space. The final frontier. All right, so 1/2 ln of 25. So this is going to be 1.6 minus 2 to the 5th is 32. So 3.5. So our answer should be approximately 4.5, 3.9, I believe. Negative 3.9. Let's see if that materializes. So 1/2 ln of 25. Well, we just said that we can move that 1/2 to that location, and that's going to be the numerical activity that we're looking for. We can move the 5 to this location. All right, now we can change this to E notation, the ln of e to the 1.6, and that is hit by the square root symbol, minus ln 2 is e to the 0.7, and that's raised to the 5th power. And what do you do with these exponents? You multiply them. All right, so that is 5 times the ln of 2, right? Coming right back to it. Coming right back to it. Minus the ln of 2 with a square root, which is the ln of 2 to the 1/2, which is e to the 0.7 raised to the 1/2. We can see 1/2. Did I write that? 1/2 of, no, I botched that. Oh, it was 25. I wrote the wrong thing here. I'm going back a lesson set, I think. All right, so I botched that. So that should have been, oh, I had it here. E to the 1.6. I don't know what my brain just did, but that was 1/2 times 1.6 should be, I made a mistake here. 1/2, 5 squared. Oh, this was 5 squared. All right, I'm botching this, but the rules of logarithms here this should have been 5 squared, right? So 25 is 5 squared, and we can see the cancellation. So that's why I had 1.6 when I just did it. Mental math. All right, I'm talking, I'm writing. That's one of those. Learn from your mistakes. Hopefully I'll be more careful with that the next lesson set. Okay, but that appears to be correct. This is the one I really botched the other day. Can't believe it. I haven't made that mistake in years. I don't ever remember making that mistake. So if x equals 3, there's the original question. If x equals 3 as a root, oh boy, hope I didn't copy this wrong, then x minus 3 is a factor. And that's where I didn't spot my mistake in the last lesson set. And I went looking at the mechanics of this, and I knew the graph wasn't right, and I knew it was wrong, but I also knew that I'm erasing these problems and I'm not going to write them down again. So what do I have to multiply by to get, and I'll write it here, so I try not to make the careless error this time, minus 9x plus 45. Now I know that if that's a root, then the other roots can't be a remainder. If that's a root. Well, let's just do it out. X squared, that gets me minus 3x squared. I want minus 5, so minus 2x times x gets me the minus 2x squared, and the minus 3x squared gives me that. Minus times the minus positive 6x, so I got to go down 15, right? Because I got to get to minus 9x, and that times that is 45, so this is correctly done. Thank you. When does that equal 0? Well, nicely factored here, x minus 5, x plus 3, and now I can see my answers. 3 comma negative 3 comma 5. Okay, it's good to also try to correct what I knew I was getting wrong. Is I know that on the y-axis 45 is my y-intercept, and I'm going down at 9 to 1. So that's what I know. I know I'm going down. So therefore it's a positive cubic. So it's got to look like this. It's got to look like this. It's got to look like that. And what I'm finding out is that at negative 3 and whatever, I already erased the answers. I'm assuming that's negative 3. So positive 3 is over here, and I think 5 as well. So I didn't draw this very well. Okay, these should be the same distance. Right here and here and here. All right, so I think I captured what I think I remember from a moment ago, but my short-term memory lasts about 10 seconds now. All right, this could also have been written as 3 sine parentheses 11 pi over 6 with a bracket and squared. Okay. By moving the 2 here, I'm cutting down on 2 strokes of the pen, and that's my definite simplification. How many strokes of the pen does a problem take? So writing it this way means that, and what's the order of operation? Doing what's hardest first, and in this case, it's in the parentheses, in the brackets. So what's the sine of 11 pi over 6? That's minus a half. Let's do that first. Make a circle. Let's cut it into 6 parts. Good drawings get good answers. So that means 12 pi over 6 is once around. I want 11, which is right there. And there's my minus 1/2. Squaring minus 1/2 gets me 1/4. And 3 times 1/4 gets me 3/4. And that's the answer to that calculation. Okay, so a little practice, little times table. That's what TT stood for over there. Times table practice. And by doing it again tomorrow and the next day and the next day and the next day, a little 30 seconds here, a little 30 seconds there. Might not be 30 seconds for you yet, but after 4 days of this, I'm hoping it gets down to a much quicker pace. Domain. Critical numbers are 0 and 4. Those are the only critical numbers in this problem. We're not dividing by 0 unless we put a 4 in. And what is the domain of a logarithm? The parentheses has to be bigger than 0. So that cancels out all these numbers right off the bat, and that one as well. These x's, can I put a 1, 2, 3, a 1.5, a 3.9999? Yes. Yes, I can use those numbers. Can I use the number 4? No, I can't divide by 0. Can I put bigger numbers in? Yes. So what do we have? We have 0 to 4 union 4 to infinity. That's the domain of that calculation. Average rate of change. Of course, I didn't put the X values in. And do I have the paper in front of me? No, I already put it in a notebook. So therefore, I'm going to make some up on the fly. Let's go from -2 to 3. I think that's what I did in the last lesson said. So if I put -2 in, I'm at -16. Plus 10 is -6. I hope that's not a careless error. If I put in a 3, I've got 54 minus 15 is 39. All right, so average rate of change is the slope. So from -6 to 39 is 45 units. And from -2 to 3 is 5. So this is going up at 9 to 1. All right, that's in graphing form, but I got to go get the lights on. All right, so that's in graphing form. There we go. The room next to mine has the same light switch. So when somebody shuts the lights off in there, which I'm glad they did, leaving a room and shutting the lights off is a good thing. So let's graph this because it's in graphing form. 2x cubed minus 5x, yes, is the same thing as 2 times x minus 0 cubed minus 5 times x minus 0 plus 0. And that's the graphing form for a cubic. So I have a linear function going through 0, and I have a perfect cube, and I'm adding these two graphs together. And if I do, I capture pretty much the linear for a while, but then the cubic takes over. I capture the linear from a while, but then the cubic takes over. That's not drawn too well, but that's 0, 0. All right, and I want to know the average rate of change from -2 to 3. So somewhere in here would be -2. Somewhere up here would be 3, right? And I'm looking for that rate of change, and it's 9 to 1. All right, so I took care of those. I'll erase that on my time, not yours. All right, repetition's my friend. Square root of 3. So therefore, the tangent, which is height over width in the unit circle, is equal to 1 over √3. Okay, so this is your triangle, your 30-degree triangle. That's √3 over 2. That's 1/2. That's 1. We've established that. Let's double everything. If we double everything, then this is 2, same angle. This is 1, and this is √3. I see 1 over √3 coming from a 30-degree triangle, that ratio. So I know I've got that ratio. Where does it happen? It happens on 2 triangles. One here, that's positive, and also here, because that's negative and that's negative. So I've got 30 degrees, which is pi over 6. And there's 6 of them, and one more makes 7 pi over 6. And that's the solution to this calculation on the unit circle. All right. Hopefully, that means a little bit more to you today than it did the other day. Okay, keep in mind, if we have an angle, let's call it x, and we have a hypotenuse that's 1, then this is the sine of the angle, and this is the cosine of that angle. If it's 30 degrees, then I get a half. Well, 30 degrees would be much lower, but that is a very important triangle to start getting in the old noggin. Okay, so what's the tangent? Sine over cosine. I'm referring to this as height, and that is width in the unit circle. Okay. Let's get rid of, no, I'm sorry, I erased, yeah, well, I need the space right now. So, sum of 2 cubes. Cube root of 8x to the 12th is 2x to the 4th. The cube root of 27y to the 3rd is 3y. That's all I need to know to build the rest of this. So I square that, that's 4x to the 8th. The product is 6. I'll make it -6 x 4y. I square the last term, 9y squared. Boom, I square, well, let's look at, I think this one yesterday gave you a little issue. -7/2. -7/2, and it's a square root function, so it's going up twice as fast as the parent function because of that 2. X plus 2, -2. Negative 2 is bigger than negative 7/2. So we only have one answer here. Let's find it. 2x plus 7 equals x squared plus 4x plus 4. So 0 equals x squared plus 2x minus 3. So therefore x minus 3 plus 3, sorry, times x minus 1. So 1 is the answer. So at 1 we get an intersection. Minus 3 is that fictitious answer right there. Fictitious answer. All right, because we only graph the principal square root, no plus minus. So only one answer, x equals 1. Let's check it real quick because I made a mistake yesterday. 1 plus 2 is 3. The square root of 9 is 3. We're all set and done. And if I put negative 3 in, I probably get a negative equaling a positive. Negative 3 is positive 1. Negative 3 is negative 1. Positive 1 does not equal negative 1. All right, it's close in some respects. With my eyesight, I might have seen them as equal. E to the x as I go to infinity. Well, I hope you have e to the x in your mind's eye. Boom, 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 y equals 0. I hope you have e to the x. E to the 0, 1, e to the 0.72, e to the 1.13. Where am I headed? Going to infinity. Bigger number, more 2.71 times 2.71 times 2.71s. All right, so you put that on your answer key. You don't even have to write it out. You just put it down. You keep moving. All right, quantities. When you subtract exponents, it implies a division of quantities. And base 4 on this side is base 4 on that side, so that's equal to 16. So therefore, x plus 1 equals 16x. 15x equals 1. 1 over 15 is the answer to this problem. Let's hope I didn't make any careless errors on it. All right, piecewise. Well, I'm cutting to the chase from now on. All right, I'm hoping you're seeing 110 as the vertex. You can check out why it's down 18 on the left and up 18 on the right. Let's get the y-intercept, put a 0 in there, and show that 110 on the left side. The left side, I'm doing the left side. Put a 0 in. 18 plus 10 is 28. All right, so how do you get from 28 to 10? Let's put this here, 0, 28. How do you get from 28 to 10? You go down 18. How do you get from 0 to 1? You go up 1. So there's our pieces. All right, so what are the two pieces? Let's talk Alfred Hitchcock. Down 18, sharing the coordinate 110, x minus 1 plus 10. That's only true when I hinge this at 1. So x is less than 1. And over here, I've got, where am I? Up 18, sorry, up 18, x minus 1 plus 10, comma, when x's are greater than or equal to 1. Those can be put into a computer. With that language, you'll get this graph. All right, you're given instructions to the machine. Let's erase that. Now, for solving, might be quicker. I used to use the pieces for this. I probably should have kept that on the board and shown you that you can use the pieces. But we want to equal, I erased it. No, that's 28. Oh, so we're done with that. All right, so we're doing equals 28. I'll do those two problems here right now. All right, because that way I already have it written. Equals 28. So we're going to make parentheses out of this and just solve from there to get one of our answers. And remember, 1 is not a solution, right? That gets us 10. So it's not a solution, but it's going to get us the symmetry, which will get us our other answer quicker. So there's our 18, there's our 6, there's our 12, and there's our 2. Check that out. 12 minus 6, 6, 18, 10, 28. Okay, so 2. So we're only 1 unit away here. 1 unit from there. 0 and 2 should be our answers to this problem. If we put a 0 in, we get negative 6. Absolute value of negative 6 is the magnitude of the number, which is 6. Times 3 is 18, plus 10 is 28. So it seems like it checks. And then we were going to figure out when this function, when is it greater than 28? Well, now that I have that, I know it's true, false, true. Okay, because it's V-shape up. V-shape up, and when am I bigger than 25? Bigger than 25 for those X values. The ones starting here at 2 and starting here at 0. So my answers are negative infinity to 0, union 2 to infinity, yes or? Back me up. If I'm making any careless errors, just show it in the introduction paragraph. Just write a comment to me as you usually do. I appreciate it because when I do this much volume, I talk at this speed. It's like, well, I won't make a political comment. All right. Some interesting news today about carelessness. All right. All right. So now, those were the two questions that were over here. But it was quicker to do them over there. So 4a squared can only come from 2a times 2a or from 4a times a. When you have a problem like this, always start there because whatever number you pick, it's going to be 3 times your size. So I'm not going to put a 3 in here. That gets me 12. But a 1 and a 3 here, oh, that gets me 4a and 3a. 1a apart. So I want this one and that is writing that as a product. When the coefficient isn't 4, slightly more difficulty, more possibilities. And there is a way to nail some really tough ones by factor by grouping. Not going to teach that right now. Might talk about it later in the term, but this practice is where you're at right now, so get some practice. All right, so I see x equals 5 is an asymptote, so I know that goes here. I'm going to do that first. All right, if I was just doing this for myself, I'd start at 1947. I'd go down 47 years. I know it's a log. When I drop a 9 in, I look at 5 to 9, that's 4 units of change. And when I look at 5 to 17, that's 12. So I've got 4 units of 12, 12. So this is a base 1/3 graph. All right, now put the numbers in, see how they work. 9 minus 5 is 4. 4 divided by 4 is 1. Any log with a parentheses and a 1 in it requires a 0 exponent. And a 0 exponent gets rid of the 47, leaving 1947. When I put 12 in there, 12 minus 5 is, wasn't it x minus 5 here? All right, so 12 units of change. Sorry, when I put 17 in, I get 12 units of change. All right, and 12 divided by, oh God, where was I? 4, this was a 4. Yep, got myself in trouble here. 12 divided by 4 is 3. Glad I did this. I might have just found a careless error. 12 divided by 4 is 3. Ah, I see. Okay. All right. So it's a base 3. Right? And the minus sign means I could have written it as a plus 1/3. Okay. So got a little reflection going here in the next problem. Probably already got my mind on that. So I should have done it from left to right the way I normally do. But I wanted to highlight that statement because people often are giving me horizontal asymptotes. And the asymptote for a log comes from the parentheses equaling 0. Right? That was what I wanted to stress, but I got myself in a little trouble because I didn't do it from left to right. Let's do it from left to right for this one. Oh, this one might get me in trouble because I don't usually do reflections. Well, we got a little reflection around x equals 5. So I am going to start with 1900. I'm going to be careful here. 1900. To get to 1947, I got to add 47. It's a log. I still have to have 5 as an asymptote, but because my x values have to be less than 5, I'm writing 5 minus x. Now, when I put in 1, 5 minus 1 is 4. That gets me 4 divided by 4, which is 1. The exponent you put on top of any base right now is a 0 to get a 1. So 0 times 47 plus 1900. I'm okay so far. Now, when I put in 1, I put in 1 already. When I put in minus 7, I get 12 over 4. So that is a base 3 log, right? Because 12 divided by 4 is 3. And that gets me 1. That adds 47 to 1900. So 1947. Okay, I think I'm okay now. Hope I didn't make a careless error up there, but I'm just going to continue on and erase that on my own time. Repetition is my friend. All right. Since it's X, what we can do in this situation, and you can't always do that, but pretend you're solving this for that number. The input of this is the output of that. So what would I do? I would -5 becomes +5. Multiplying by 2 becomes division by 2. Logging base 3 is the same as 3 to the and -4 becomes +4. Let's check that. Let's see if it is true by putting in a friendly number. I'll put in 7. 7's friendly. 3, base 3, 1, 2 minus 5, -3. If over here, -3 does not get me 7, I will catch a careless error. -3 plus 5, oh, I like that, that's 2. 3 to the 1 is 3, plus 4 is 7. So what I said before, and I don't even remember what it was, x plus 5, I believe, appears to work. So that is the inverse. All right. Let's cut to the chase and do this problem from here. 1/4 is 2 to the -2. 8 is 2 to the 3. Rules of exponents, because the bases are the same. The rules of exponents, the exponential activity has to be the same. -2 times x minus 5 is -2x plus 10. 3 times 3, I'm trying to be careful. 9x plus 6. I'm moving the 2 that way. 11x, I'm moving the 6 that way. 4, my answer should be 4/11 for that problem. Hey, one more reminder. I shouldn't remind at this point, but if you want to do these problems, pause the video. If you want to just watch me, that's fine. That's enough practice for the day. All right, 1/2. All right, I'm going to write this in E notation. 1/2 is e to the -0.7. Rules of exponents mean I can move the -0.7 to here. I know how to divide by 10. I move the decimal place 1 unit to the left, and that's your answer. That's equivalent to 70 t over 10. And a lot of times you'll see these on college board tests, like 0.23. 0.23 is an e to the 0.690 something. I forget what follows it. That's a little better approximation. And if you divide that by 3, you get 0.23. So what you really have is a doubling every 3 years. All right. And sometimes that is helpful for multiple choice tests. You don't have to go to the calculator. You can look at the answers and figure things out. All right. Just a little tidbit for folks who are heading in that direction. All right. So we're doing these graphically now. You can always do a sign chart. We're going to do it graphically. So there's my x-axis. I have 0. No sign change there. 3 to the 1, that's a sign change at 3. I now have a kind of a approximation scale, -2, maybe right about there. No sign change. I know my end behavior. I haven't talked about end behavior, but -4x, 3, 4. -4x to the 4 is a graph that looks like that. So I know my end behavior. Boom, boom, boom. That's what the graph's going to look like. I don't know what these are. That's what calculus is about, finding local maxes and mins. I want to be greater than or equal to 0. Well, that's easy. That's -infinity to 3. I can see it from the graph. Hopefully no carelessness there. All right, so pause the video. Well, you will. We have modern technology now. You can always go forwards and backwards by grabbing that little circle on the bar and my, oh my. Ooh. Oh, sorry. Keep going here. Hopefully I don't run out of battery. So let's reduce this. That's equal to the tangent of divide by, no, I can't reduce that. 61 pi over 6 is pretty darn close to 60 pi over 6. That's 10 pi. 10 pi is even. So I know I'm over here. And I got to go 1 more pi over 6. Good drawings get good answers. Halfway up. Right? There's halfway to 1. So, but we're doing the tangent function, so I'm not going to have 1. I'm not going to be a unit circle here. I'm going to do a 2, a 1, and a √3. And so what is the tangent of 61 pi over 6? Opposite over adjacent, because this is x, the angle. That's the angle, calling it x. Okay, and this is the kind of the arc length distance on the circumference. Well, of course, I did 5 times around and then that. So answer 1 over root 3. All right. Maybe you can start doing these in your head. 64 minus 9, 55. 24, 48. Okay, now what did I do? I did the square of that is 64. I doubled that product, which is 48i. I squared 3i, which is 9i squared. 9i squared is -9. I took -9 from there, so no carelessness there. Pretty sure that's correct. WAAP, right as a product. 9 minus 4, difference of 2 squared. Any difference can be written as a product. A minus B can be written as a product. Square root of A plus the square root of B times the square root of A minus the square root of B. Okay, this is just a special case where the numbers are user-friendly. So 3 plus 2 times 3 minus 2. Right, so difference of 2 squares. You work with the square roots. Add them and then subtract them. All right, let's move on. Now let's do a quick solve. Subtract 9, divide by 2. Ln becomes e to the 1/2. E to the 1/2 becomes the square root of e. 5 minus x, let's make sure I don't make a mistake here. 5 minus x, I'll bring the x to this side and the square root to that side, and that's your answer. And I see I captured that on the camera. 7 minus 3i. I got to learn from my mistakes. Yesterday I made a very careless error. I forgot to square the 3. Mental math. I won't now. 49 plus 9 should be 58. So this should be x squared minus 14x plus 58 equals 0. But I made a careless mistake yesterday. Let's do it out. X minus 7 equals plus minus 3i. I only gave you one root, but they come in pairs. X squared minus 14x plus 49 is equal to this thing squared, which is 9i squared, which is equal to -9. And yes, when I bring it over, no carelessness today. All right. A little more sleep too. 5 root 27 is 5 root 9 root 3 plus 3 root 4 root 2 minus 2 root 4 root 3. All right, so what do we have? We have a singleton here, 6 root 2. That one is minus 8 root 3. Oh, sorry, minus 4 root 3. Almost made careless error there. I can tell I'm getting to the end of the video. And this one is 3 times 5, 15 root 3. And so I do have likeness here, so that's 11 root 3 plus 6 root 2 is that problem. This, measuring from 5, how far do I have to go? 7 units. I got to go up 7 units to get to 0. But I'm going to be squaring, so I got to get rid of the squaring with square root, and I'm going to be multiplying, and the real roots are right there. So no imaginary roots, there are intersections. All right. Point of inflection for the next cubic. How do you find the point of inflection? It's the average of the roots. You can look at completing the square video and get the geometry behind y. It's on the playlist. And putting these in graphing forms on the playlist. And you are going to be graphing these, so look at the playlist. All right, so 3. So minus 3 divided by 3 times 1. So -1. If I put -1 in, I get negative. Well, I can put it in here, right? But the shortcut when it's a bigger number is that's -1. So I double it and change the signs, and that takes care of that addition. Minus makes that positive 20 plus 15 is 37. So what did that look like? I'm going, did I make any mistakes here? This is what I made a mistake yesterday. 3 minus 1 is 2. Minus 20 becomes positive 20 divided by 3. So I made a mistake. By doing that, I saw a plus. It's minus, right? No, okay, -1. Was it a plus? Oh, God. Now I've played with it. I can't believe it. I just played with it and I don't remember what the original was. Now I can't find out if I have a careless error. All right, so let's make this a plus. Let's look at the graph real quick. I'm starting at 15. I'm going up at 20. Going up faster and faster. So that's what that graph looks like, if that's a plus. That's what that looks like. So where's my point of inflection? Where am I going up least quickly? Probably right there. That's where my point of inflection is. So now, +3, I don't think I graphed that well. Oh, that's a positive slope, right? That's a positive slope. All right, so I'm going to do this out and take a little more time. So -3 divided by 3 is -1. So that was misleading to me. So -1, I have to have an answer that if this is 0, 0 gets me 15. Now I know I need a number less than 15 or I've made a careless error. All right, so I've got to put -1 in here. And that is 2. That is -20 plus 15. That is -3. Now I'm feeling more comfortable, right? And I know I'm going up at 20 to 1 right here. I have to be going up less quickly there, less quickly. And the geometric explanation and completing the cube will show you why. So now where was I in my thought process? Oh, C minus 3AH squared has got to be less than 20. Yeah, +20. It's got to be less than that. All right, so let's find that real quick to see at what rate I'm going up, and then I'll put this in graphing form. No reason not to. So C is 20 minus 3, A was 1, H was -1 squared, and so that is equal to -17, and +17, sorry, and 17 is less than 20. So I'm going up at 17 to 1 right here. So the graphing form for this would have been x plus 1 cubed minus plus 17, x plus 1 -3. If you multiply that out, you should get this. And there's more talked about in completing the cube graphing. It's about a 25-minute video, and I tackle this in more depth. All right, so that's that. Let's get rid of that. Let's get rid of this. What did I ask you to do? Probably y-intercept. If I asked a question like this, I'm looking for the y-intercept. You put a 0 in, the ln of 1 is 0, that cancels. You put a 0 in here, and you get 14. Wasn't there an ln there? No, there wasn't an ln. So I put a 0, I get 14 plus 3 is 17. So, interesting. I guess I put this in graphing form, but forgot to write it as a log. What did I do here? Not sure. There's some interesting coordinates here, but 0 gets me 14. That's what I asked. 14 plus 3 is 17. I think I just got some coincidences here with some numbers that were on the last problem. Throwing me off. End of the video. You can see where my cognitive decline is showing again. Coordinates. You got to be able to graph these. In calculus, you got to be able to graph those. Hopefully you look at x times x plus 6 and get a 0 and a -6. That's what that graph looks like. Y equals x. Well, that's going up 6 to 1. So y equals x is going to look something like that, I think. And we're going to look for those points of intersection. And then you'll learn how to find that area in future classes and what it stands for. All right, so we're going to find that by bringing the x over. X squared plus 5x equals 0. We're going to factor out the x plus 5 equals 0. So this one would have been -5. This one would have been 0. Yeah, they have to go through here, right? So 0 looks good. And if I put a 0 into that function, I get 0. And if I put a -5 in, I get -5. And let's check it by putting -5 here. 25 minus 30. It's a decent graph. And it's a decent skill to start trying to pick up. All right, so looks like I'm getting a phone call. Oh boy, I can't take it right now, but I will check the text in a moment. So let me fly through this because I got an appointment here I got to keep with that phone call. Y-intercept plug in a 0. Just want to make sure people know that the cube root of a negative is a negative. -2 plus 7 is 5. 0 gets you 5. I'm really gonna have to rush now. All right, so no explanations, mental math. All right, so I want that to be the sine function, and I can see that, where am I? 1500, x minus 1500 gets me a 0. The sine of 0 is 0, and I want 30. And then I'm gonna do 1 pi, 2, 3, 4, 5, 6.5, 6.5, 6.5 pi. I didn't leave enough room. 6.5 pi. And that took how many years? It took 400 years. Box, and I'm going up and down from 5 units. All right, so that's that function. Get my eraser. Yeah, I probably should answer that phone. Y equals 3, so I've got y equals 3 plus 47 takes me to 50. 3 to 20 takes me up 17. X minus 29, and I've gone 18 years. All right, so that's that function. Number 90, y equals 0, puts an asymptote, x is 0, so that's an asymptote. I'm going to 0, and I need 3, so I need 3 times whatever makes a 2 x minus. I want a 3, and that's a 2, so I need 6x. I need, oh God, x minus 2, right? And that wants to be a 3, so I need, the brain is really shutting down. Just 3x. And that needs to be 3x, so I put a 2 and I get 6. Divided by 2 is 3. Oh God, so it's just 1 over x. That's what I'm looking at. I'm looking at 1 over x, and I want a 2 to get me a 3. So there's no x-intercept. That's my issue. There's no x-intercept. So there we go. So we put a 2 in, right? And we want 3. So that's it. It's just 6 over x. Sorry, that took me a moment because I'm under pressure. 7x plus 2y equals 21. So we got an x-intercept at 3. 3 gets you 0, and we got a y-intercept at 21 halves. 21 halves up here. 0, so you're using zeros and connecting the dots. All right, 3x squared minus 12x plus 5. Cup shape up. 12 divided by 6 is 2. Put in a 2. Minus 24. 12 plus 5 should be minus 24 cut in half is minus 12 plus 5, negative 7. And we have 0 gets us 5. 0 gets you 5 over here. Hopefully that's correct. All right, now we got to move Rene Descartes here. Just trying to get you practice at this point. So, can't talk about things right now. I've got y equals 5. I've got to put a 2 in. If I put a 2 in, I get 9. 2 gets me 9. That should be there. And then my next jump is going to be 12. 12 and 5 is 22. And I want this to be 1.1, 3.3 plus 2, 5.3. There you go. There's your practice for that. I can erase that now. Hopefully. Yasser, sharpen your pencil. X equals 2. That makes a 0. I want a 1. 5 halves gets me a 1, which means I get 5. Hopefully it's it's the inverse of decay. And now I want 3. 3 plus 4, 7 halves. That gets me 1.1, 3.3 plus 5, 3.3 plus 5, 8.3. All right, so hopefully that's correct. All right, next one. 1800 pi over 2. So I'm going to do this from the standpoint of max. I'm going to make 1800 equal pi over 2. And that gets me 1 times 25. 25 plus 100, 125. Then I want 3 revolutions, 3 pi. 1, 2, 3 to get to there. And that's changing my 91 years. So 1891 should get me 25 from 175. That should be that one. Done. All right. got a factor, x plus 2, x minus 2. 3x minus 6 is 3 times x minus 2, so we have a point of discontinuity at x equals 2. We're going to have to find that y value after we graph 3 over x plus 2. That goes to 0. That goes to 0. And therefore, we have y-intercept of 0, 3 halves. And we have asymptote at x equals negative 2. So we've got a no x-intercepts, no x-intercepts. So this has to come this way. That has to come this way. And at 2, we are going to get a point of discontinuity at 2. And if I put a 2 into the reduced fraction, I get 3/4. Boy, I'm getting another phone call. All right. What's the limit of f of x as x goes to infinity? 0. What's the limit as it goes to negative 2 from the left? From the left is going to negative infinity. When am I less than 0? When I'm less than 2. Minus 2. So that's negative 3, 5. And I've got to answer this phone. Dang it. All right. This video is over. I will include those videos at a later date. Sorry, folks. I'm not going to do it again. All right. I'll put an addendum after I answer the phone call. That's what I should have done to begin with. All right. So let me push that. And